Hi, I'm Professor Clements, and today we're going to talk about significant figures. Now, in another video, we talked a little bit about why significant figures are important, why we'd want to care about them if we want to know something about how precise we measure a number, say the number 100 versus the number 100.0. The second one implies that we measured it a little bit better. So it turns out there's a few rules that we need to know about how to count significant figures. How do we know how well we measured a number? And that's what significant figures are all about. Turns out there's some simple rules. The first rule is pretty easy, is all non-zero numbers are significant. What does that mean? It says that somebody actually went out and measured that number. So if we have a number like 357, someone actually went out and they measured the 300, they measured the 50, they measured the 7. And so we say that this number has 3 significant figures. SF for short, significant figures. Now, if we had a decimal point after that, if we had something like 10.53, what we mean is that someone knows that it's exactly 10, someone knows that it's exactly 0.5, and they went out and even measured the 3, and we count this as all significant. Now, I just realized I put another rule in here when I did the 10. I'll get to that in just a second. So that's got 4 significant figures. We'll get to that 0 in a second. The second rule is that leading zeros are never significant. So if we have a number that starts with a bunch of zeros, none of those zeros mean that we actually measured them as 0. So 0.00035, those leading zeros that we have there, all they're meant to do is tell us about how small or how big the number 35 is. So we've got this number 35 down here, and these zeros just tell us, oh, it's a very small 35. No one actually measured those zeros. They measured this 3 way down here. And so we say this one has 2 significant figures, because these non-zero numbers are significant, but these zeros are not significant. Now, rule number 3 we're going to have to do by erasing here. Rule number 3 is that sandwiched zeros are significant. Okay, so what do we mean by a sandwiched zero? Well, I did it by accident in this example down here. I said that number 10.53 had 4 significant figures, and I had a little sandwiched zero in here. Sandwiched between non-zero numbers makes it significant. Somebody actually knows that that's 0 as opposed to some other number. It also works for numbers with lots of zeros in a row. So the number 1005, of course, these non-zero numbers are significant, and then these sandwiched zeros are also significant. So we say that this has 4 significant figures. Okay, so sandwiched zeros are significant. Whether they are before the decimal or after the decimal, it doesn't really matter. All the sandwiched zeros are significant. Okay, so what's our next rule? We've got leading zeros. We've got trailing zeros. We've got sandwiched zeros. We've only talked about 2 of them. So our fourth rule is trailing zeros are not significant unless there is a decimal space, or decimal point, I should say. Okay? So if there's a decimal point, they're significant. If there's not a decimal point, they are not significant. So let's look at a few examples here. So we're going to talk about numbers with trailing zeros. Now, there's numbers with trailing zeros that are bigger than 1 and numbers with trailing zeros that are less than 1. So if we say the number 10,500, we want to know how many significant figures that has. Well, we know the 1 and the 5 are significant. We know this sandwiched 0 is significant. What about these trailing zeros here? Well, without the decimal point there, we know that they're not significant. What does that mean? It means that someone knows that this is 10,500, but they actually don't know what the value of these next digits are. It could be 10,534, 10,507, 10,543. We don't really know. So we don't know these values, but we know these values. That's what significance means. And so we call this having 3 significant figures. How about after a decimal point? If we have a number like 47.500, what do we say about the significant figures there? Well, we know that the 4, the 7, and the 5 are all significant because they're non-zero. What about these trailing zeros here? Usually not significant, but there is a decimal point here, if you see that there, which makes all of those numbers significant. And we have 1, 2, 3, 4, 5 significant figures in this number. Okay, let's do a couple more examples just to see how this goes. Okay, let's compare the number 340 to the number 340.0. Well, let's look at this number. What do we know? These are significant. What about this one? Well, I didn't draw a decimal point, which means this one is not significant. And he's got 3. I don't know why I said 3. He's got 2 significant figures. Whereas this one over here, I know these are significant. What about these trailing ones? Well, I put a decimal point there, which means all of a sudden all the trailing zeros become significant. Even this one that wasn't significant before becomes significant because of this decimal point. And I'd say that this number has 4 significant figures because all those trailing zeros are significant. Okay, let's do some more examples. Okay, what about if we have a number like, let's say, 0.003050. Here we've got lots and lots of zeros that we have to worry about. All the different zero rules are here. So what do we know? Well, we know the 3 and the 5 are significant. We know this sandwiched zero is significant. These leading zeros, not significant, because leading zeros are never, ever, ever significant. What about this trailing zero? It is significant because of this decimal point. So we have 1, 2, 3, 4 significant figures. And again, it means that we know that value is 0. We don't think it's 3 or 5 or 7. Somebody actually measured that and knows that it's 0. What about if we have something like scientific notation? If we have 4.30 times 10 to the 5th. Now, if we wrote that out as a decimal, we'd write 43, let's see, 10 to the 5th. 10 to the 5th, you start getting used to this, is in the 100,000s. So this is 430,000. Now, it looks like when I write that number that it would only have 2 significant figures. However, because I wrote it in scientific notation, I'm going to use the scientific notation to figure out my significant figures. And this number actually has 1, 2, 3 significant figures. Whenever we write scientific notation, we're going to use the coefficient here, the number in front of the exponent, to figure out our significant figures. We're not going to write it out as a number and then try to figure out our significant figures from there. Always use that coefficient. And that's really useful, because what if we had the number 430,000 and we needed to say, oh, we measured this as a 0? Well, we'd have to write it in scientific notation, because that's actually the only way to get across that you've measured that 0. If you write it like this, you can't do it. So hopefully that helps clear up how to count significant figures. If you're still confused, there's lots and lots and lots of information available on the internet. Go search for significant figure worksheets with answers, and you should be able to find some practice as well. And hopefully on my site, ProfessorClements.com, I'll add some work on significant figures soon as well. So thanks for watching my video, and good luck with your homework.